Hey everyone! Today is an exciting day because today you and I are going to talk about service-oriented architecture. Well, not in the way that you think. I'm not going to talk to you about microservices. I'm not going to talk to you about the different types of service-oriented architecture you can have at the infrastructure level, but we are going to talk about having a service layer in your server. Now, let's get into it. So, what do I mean about having a service-oriented architecture in the code base? You have to know that there's a difference now, because if you go out now and you start searching for SOA or something like that, which is going to net you a lot of different articles about how you used to do service-oriented architecture at the infrastructure level. It is actually think of it as something that came way back. Well, way back may be a strong word, but it was there before microservices became a thing. Microservices is, a lot of people still argue that microservices is just a trend word for service-oriented architecture. But what do I mean when I say a service-oriented architecture at the server level? Well, you see, traditionally a web application will be structured according to the MVC pattern, which means that you have a model that takes care of saving and doing stuff with the database. Basically, that integration code is going to be in the model. And then you have something like the view, which is going to be responsible for showing information and sending information and all that good stuff to your consumer, the client, if you will. And then you will have the controller. And the controller's responsibility is to handle the incoming request, map that to a desired outcome. Basically, the controller is responsible for making sure that the thing that is expected to happen when somebody makes a request to a certain endpoint on your server is actually happening. Now, what happens a lot of the time, and I see this is especially true for web application developers who haven't been working in the more, let's call them corporate languages. This architecture is something that I learned back in the university from my tutors my teachers who, they've been working in Java for most of their career. So they know their stuff. They were really good. They were really good, actually. And so what usually happens, which I can see a lot, and it was actually the case at my first job, we were making a Node.js server, basically. And so, here's Frederick, fresh out of college, starts coding and starts doing a service-oriented solution, if you will. And to define that, what usually happens when you have a controller, and you see this a lot, is that let's say that you have an endpoint such as a post request is going to come in and it's going to be mapped to /users. This is very common. What usually that means is that, all right, we're going to send some form information or JSON or AJAX or whatever you want to do, and we're going to create a user. That's the desired outcome. Now, in your first iteration of this application, this will be a fairly simple, naive implementation. The first thing that's going to happen is that you are going to parse the incoming form information, pick off the information that you need to create a user, such as a username, email, password, these sort of things, basic stuff. And you're going to save that to the database. Said and done. You're happy with yourself. Good job. Pat yourself on the back. And then somebody comes along and says, hey, you know what? We can't really allow the user to have just any username, right? Because what happens if a hacker starts trying to do something like copy paste the entire memoirs of all the collected work of Shakespeare into our input field? How are we going to deal with that? And you say, don't worry about it. I'll fix it. So you go back to your code and you set a threshold for, you do an if condition basically, which checks the username length in the incoming information. And if it's too long or maybe too short, you'll simply send back an error. Easy, right? And then you're committing that code, you pat yourself on the back. Good job, Frederick. Nicely done. Then your boss comes in and says, but shouldn't we do that for passwords as well? Because, we don't want people to just, what happens if they pick a really bad password like 123? What do we do then? And you say, okay, sure, I'll fix it. You go into the controller method, which is now starting to grow a little bit, and you put in another if condition. And you check, all right, if the password is between 6 and 8 characters, that's usually a safe one, right? Then we will simply say that that's a valid password. And if it's not, we'll simply send back an error and say, hey, your password is too short. Pat yourself on the back, good job. And then your boss comes back and says again, well, maybe we want the password to include special characters because, we want it to be really secure, right? And you kind of go, okay, let's put another check in our controller to check if there's special characters and that you have the right ones and that the sequence is correct and all of that good stuff. And now there's a third if condition and maybe a fourth and a fifth, and it keeps on going and going and going and going and going until your controller method is massive. Just trust me when I say, from experience, the controller method is easy. I've said this before, and you've probably heard other coders who are much more experienced than I am tell you about how easy it is to come to a point where you have spaghetti code and you have these methods which are 500 to 1,000 lines of code long. The controller method, hands down in my experience, is the place where this happens the most. And it happens because it's the glue, or it's the place where all things that should happen, like it's a very natural code hub. Everything that is going to happen when you post to that endpoint to /users is going to happen there. And what happens if, let's say that, when somebody creates a notifications, let's say that we wanted to notify our administrators, or maybe we wanted to gather some metrics, how many people are creating accounts on our system, then you would have to add even more stuff there, and it just grows and grows and grows and grows. And that's where the service-oriented solution to this gets very effective. And basically what you go for is that you say, all right, the controller is only responsible for delegation of logic. It is not allowed to use any of its own logic. In other words, if you needed to validate that a user's information is correct, then you would create a separate file called, say, user validation service. And you put all of those checks, if the user's name is correct and the user password, all that stuff goes into that bucket of code, basically. Same thing goes for notification. You might have a notification service or a metrics service. All of these things you add in order to separate the structure of the logic, so that the controller doesn't get to be like this fat super function that does all of this itself. Now, I have had my previous boss has told me at one point, he would say, "What, Fredrik? This means that you have like these super methods that do like a bunch of stuff, like tons and tons of stuff." And his quote was, "Yeah, so it does everything. It includes everything. It includes everything, even the kitchen sink. Everything in the kitchen sink, something like that." And I kind of chuckled and I said, "Yeah, that is true." But unfortunately, you are in the situation where you have two choices. You can this is what I argue that a lot of people kind of forget when they're in software development. There is only so many things you can do to simplify a problem. Because think about it, you want all of these things to happen, as I was saying earlier with the user. They need to happen. That means that the base level of complexity for our solution is very high. No amount of abstraction, no amount of kicking and fussing and trying to structure and organize things is going to take away the amount of code that is necessary to solve this problem. There's no way. So you can choose to either have many services that do different parts and that you can actually reuse, because remember, maybe you want to do that type of validation somewhere else, or you can put it all in a single function. That's up to you. I personally find that the service-oriented approach to doing this is very, very effective. It's the way that we work at my job, for example, right now. And I think that it is a very proven method to solving this problem. And for the purists out there who say, oh, well, it's not really functional, Fredrik, if you have these methods that do all of this logic, just relax. See, the thing with functional programming is that the idea is not to have every single function or every single service or so forth be a pure function. The idea is to push your state and your impurities to the edges of the application. And all you've really done is to move the impure parts, which usually would happen in the controller function, one level down into a reusable method that is doing that impurity. So think of it this way. You just took a piece of impure code that's happening in the controller and put it in one level down into a service. And that way you have one more layer, of course, between your incoming request and your business logic and your database and all of that stuff. But it is more modular, it's more sustainable, and it's even reusable.